రఘుబాబు, హలో, గుడ్ ఈవినింగ్ రఘుబాబు. అన్మ్యూట్ చేయండి.
సార్ గుడ్ ఈవినింగ్ సార్. గుడ్ ఈవినింగ్ సార్.
గుడ్ ఈవినింగ్. లిమిట్ ప్రాబ్లం వస్తుందా 100కి?
Sir, we fixed this problem, sir. We have shared another link in the group.
Okay.
Sure, it will be resumed, sir.
Oh, okay. The SPC-SHZG-IPG అదే నడుస్తుందా?
I will let you know, sir. I will let you know in 5 minutes. Dear participants, could you please sign out from this account and rejoin with the new link we have shared in the WhatsApp group. Sorry for the inconvenience. Here only I will share the new link. Please. Dear faculty friends, link has been shared in chat box. Please sign out from this account and rejoin from the link given in the chat box.
Dr. Raghu, can you just mention what is this one, because I don't have a second option here. SPC.
1 minute, sir.
Is it the same link? SPC dash?
No, sir. No, sir. UAH.
1 second.
Dear participants, please rejoin the session using the new link.
UAH?
Dash. HSGB.
HS?
GB.
GB?
Dash. TFS.
TFS.
Yes.
we have included all civil engineering like geotech problems, water related problems, structures, everything in this. Okay. So before first I request Shravya to please do the prayer song, please. Shravya, Unama. Go ahead, ma'am.
रूपम् ॐ नमस्ते गणपतये वर वरद शुभद गणपतये ॐ नमस्ते गणपतये वर वरद शुभद गणपतये वर वरद शुभद गणपतये.
Thank you, Shravya. On behalf of our chief guest and other guests, I like our UGC students to lighting the lamp, please. And
UGC students.
yes, yes.
UGC students. Connection stable గా లేదు.
Sir, with your permission, I request the chief guest, sir. Now I request our Honorable Vice Chancellor, sir, to kindly address the participants, please.
Good evening, all of you. Am I audible?
Yes, sir. Audible. Yes, sir.
Sir, it's audible, sir.
Audible, yeah. Professor Channareddy, Principal of the College, Professor Shashidhar, Coordinator, Dr. Ajita, Head of the Department, and all other participants for this FDP. Welcome to this FDP being organized by Civil Engineering Department of JNTU College of Engineering on behalf of ATAL. So I am very happy to be part of this particular inaugural function. Actually, because of some technical issue, this is slightly delayed. The topic of the FDP is very vast, recent advances in civil engineering is a very vast topic, and particularly you have areas of new materials, new composites, construction technologies, new analysis techniques. So it's a very, very vast subject chosen by the coordinator. So it will be quite interesting to hear some of the experts in these areas. And I'm very confident that the experts chosen by Professor Shashidhar are quite good, and their lectures will be quite interesting for all the participants. So I hope this particular FDP will be quite beneficial to all the faculty members who are participating in this, and also the practicing engineers. If somebody of the practicing engineers also there. So even experts also, somebody from the industry are also giving lectures in this FDP. So that will be quite useful to all the participants. So without taking much time, I want you to start the program, the resource persons. So I wish you all good luck and hope we'll spend more time in the valedictory. Good luck to all of you, and I wish all the success for this FDP. Thank you very much.
Yeah, thank you so much, sir. Sir, even in your busy schedule, you have given us time because with your votes, all the you are like a guru of all our civil engineering faculty. That's why we are very particular you to be in this inaugural session, sir. As you said, sir, there are some. It's speakers are a part of academia as well as industry, sir. Even 3 foreign speakers also there, sir. So we have collected like it was selected in such a way that all the topics are related. So that, sir. Thank you very much, sir. Now I request our head of the department to speak to the participants, please.
All the best, Shashi. Good luck.
Yeah, thank you. Thank you so much, sir.
So, Honorable Vice Chancellor, Professor H. Sudarshan Rao, sir, my guru, and Principal of the college, Professor P. Channareddy, sir, and coordinator of this ATAL FDP, that is Dr. Shi Sheshidhar, sir, and co-coordinator Raghu Babu, and all the members. Good evening, one and all. I welcome to this faculty, the 6-day faculty ATAL FDP, that is emerging trends in civil engineering for disaster management. So it is very delightful to see so many distinguished members here today. And disaster management, this is the one of the most important and pressing challenges we face in the modern world, whether it is natural disasters or man-made calamities. So their impact on the society, infrastructure, and the communities is undeniable. So as this our civil engineers will play a vital role in designing, planning, and implementing infrastructure, which is resilient and also capable of this withstanding the forces of the nature. So this FDP, this has been designed to equip you with the latest advancements in the civil engineering techniques, technologies, and approaches related to the disaster risk reduction and management. So overall the course, you will have the opportunity to engage with the experts, speakers, and we can discuss the innovative approaches to the risk assessment. So I request all the participants to actively participate and also ask their questions and share your experiences. So finally, I will thank to our organizers and all the people for giving this opportunity. Thank you. Thank you very much.
Yeah, thank you very much, madam. Sir, principal sir, please excuse us for the late because due to this some communication, it has started 20 minutes late. So kindly excuse us. So now I request there are almost 150 participants, sir, and speakers are from different organizations, including industry. So I request you to kindly address our participants, sir.
Thank you, sir. Honorable Vice Chancellor, sir, Sudarshan Rao. Coordinator Shishidhar sir, Head of the Department Ajita Madam, Raghu Babu, and my dear participants. Good evening to all of you. So the trouble which we had for the last half an hour is just a simple example, a trivial example of disaster actually. Disaster doesn't calm people, but it causes a lot of inconvenience. But I apologize for the inconvenience, participants. I hope the rest of the sessions there will be no inconvenience for you. So I'm a computer science fellow. So I don't want to talk much about the disaster management in just civil engineering. But what happens if a disaster occurs? If it may be a civil related disaster, uh, probably building collapses, apartment collapses, or floods come. These are all the disasters that happen related to the civil engineering department. And this area is actually interdisciplinary. You cannot take measures directly using just the knowledge of the civil engineering. So what basically needs during the disaster is communication. What basically needs is a communication. So all your communication will collapse. Now, how do you communicate with other personnel? Because the disaster relief personnel should collaborate with one another. They cannot work in isolation and recover from the disaster. So there is one solution that is being followed extensively that is called as ad hoc network. Whenever there is a problem, disaster occurs because there is no communication infrastructure and because communication is necessary between the relief personnel. So what they establish is an ad hoc network, which is an autonomous network, which is a temporary network actually. And using this autonomous network, people will work on recovering from the disaster. So in this ATAL FDP, so we will learn more from the civil perspective, but it is definitely an interdisciplinary area. The cooperation or coordination between all the technical people, including civil people, is necessary. And we will learn some of these techniques or tools that are available and the methods that are to be followed while recovering the disaster. I wish the coordinator and the organizers best of luck, and thank you for giving me this opportunity.
Sir, thank you very much, sir. You are the person responsible for this online FDP because you instructed all the department to at least send a proposal. So in this connection, with your support only, we have sent the proposal and finally it has got selected. So you are the almost a man behind this FDP. Thank you very much for encouraging us. And so the last item is vote of thanks by Raghu.
Thank you, sir. Good evening, everyone. I am Dr. Raghu Babu Uppara, Associate Professor Civil Engineering Department, Srinivasa Ramanjan Institute of Technology, and co-coordinator of this ATAL FDP. On behalf of the organizing team from JNT Anantapuram and myself, I extend my heartfelt gratitude to all those who have contributed to the success of this inaugural session of the AICTE Training and Learning Academy sponsored FDP on emerging trends in civil engineering for disaster management. First and foremost, I express my sincere thanks to my guru, Professor H. Sudarshan Rao sir, Honorable Vice Chancellor, JNT Anantapuram, for his inspiring presence and encouraging words. I extend my gratitude to Professor S. Krishna sir, Registrar of JNTUA. Sir is currently not available with us. Next, I would like to give my heartfelt thanks to Professor P. Chennareddy sir, Principal JNTUA College of Engineering, Anantapuramu, for his constant guidance and encouragement. I also thank Dr. B. Ajita, Head of the Department, JNTUA College of Engineering, Anantapuram, for her leadership and contributions to this program. A special note of appreciation to Miss M. Streya, my student, as well, for the beautiful prayer song that marked the beginning of this session. I extend my thanks to the Faculty of Civil Engineering from JNTUA Anantapuram and SRIT, and especially the resource persons from academia and industry across the globe for accepting our invitation and gracing this program. Finally, I would like to thank all the participants for joining us and making this FDP a meaningful and engaging experience. Your enthusiasm and commitment to learning will undoubtedly make this event a great success. Let us look forward to productive and insightful week ahead. Thank you. Thank you once again.
Yeah, thank you, Raghu. So, my dear participants, sorry, like I once again apology, especially to the speakers. We are lagging by 20 minutes. Hopefully, we'll before the session close, we can going to cover that one. And coming to the FDP, you know the rules and regulations as given by the AACT. Just we are following that one. The attendance, examination, everything will go as per the schedule and as per the regulations given by the AACT. So without wasting much of time, I like to enter into the first topic. So the first topic of the FDP is Introduction to Disaster Management in Civil Engineering by Professor B. Kondraivendhan. So just before giving the mic to the professor, I'll just give a brief biodata on the speaker. So Professor Kondraivendhan sir is from his PhD is from Indian Institute of Technology, Delhi, and his PDF is from 9 Technological University. He is having lot of work experience. He worked as a assistant professor, associate professor from the SV National Institute of Technology, Gujarat. He has vast administrative experience. He works in various sections like a warden, a member of institute level committee, and hostel ragging committee, and for revamping of institute website. And he is a member of NRF ranking in the SUNST. He is a coordinator for material testing at Department of Civil Engineering. He has published more than 70 papers in SCI and Scopus Intech journals and conferences. He has published 2 technical books. He has having 3 design patents. His research interests are studies on RC concrete, corrosion, microstructure modeling of cement-based materials, analysis and design of high-rise buildings, analysis and designs of bridges, repair and rehabilitation of concrete structures, and alternative binders for concrete production. Apart from that, he has recognized as a visiting student of University of Dundee, Scotland. So he's a BOS member, technical committee members to act everything. So likewise, if you mentioned, it is almost a very big biodata. So stop here. So I'm very much thankful to Dr. B. Kondraivendhan sir for accepting our invitation and giving us this lecture, first lecture. Hope everything will go fine. I wish you all the best to the participants. Please enjoy the lectures, and if anything else, please put up on the message box, please. Sir, over to you, sir. Professor Kondraivendhan sir. Please switch on your mic, sir.
Yes, thank you, Professor Sasidhar, for
Yes, sir.
your nice introduction.
Yeah. I'm giving you the screen share, right, sir? Please. It's open, sir. Please.
Yeah, I am sharing. Right now I am sharing. Is it visible?
Coming, sir.
Yes, sir.
Yeah, it's. I hope all the participants are.
My screen is visible.
Yeah. Yes, sir. Please, sir. Now over the mic to you, sir.
Yeah.
Please.
Yeah, actually, I am very sorry. My video is not working, but you can see my PPT. Okay.
Okay, sir. No issues.
Good evening to good evening to one and all. First of all, I would like to thank the organizers, mainly the coordinator, for inviting me to give this presentation, the topic of Introduction to Disaster Management in Civil Engineering. So special thanks to Professor Sasidhar and also Dr. Raghu Babu for this opportunity. I am going to present my topic on this Introduction to Disaster Management in Civil Engineering. As we discussed at the inaugural function, so the disaster is a very important topic nowadays because we are all seeing a lot of news, and we are all getting a number of the things related to the disaster. If you look at the statistics and other things, the last 20 years, there are around 30 lakhs people have been died due to the disaster. So what does it mean, disaster? Disaster is an event that causes a lot of harm or damage, or we can say it is a terrible situation or event. So that's why it is very much needed to discuss. So this is a picture they have given, what will happen if the disaster happens. So people will cry like her. So that's why it is very much needed. We need to discuss this. Okay, so we should have, if suppose there is a disaster happens, then what will happen, what is the consequence? So there is a material and infrastructure will damage. So that's why we should have some awareness how we can mitigate the disaster or how we can minimize the damages. That's why we need to discuss about the disaster management. So according to the WHO, the disaster means that any occurrence that causes damage, ecological disruption, loss of human life, or deterioration of health and health services on a scale sufficient to warrant an extraordinary response from outside the affected community or area.
Sorry,
So,
Professor. It seems your slides are not sliding.
Acha. Okay, what's the problem?
Yeah, now it's moving.
Yeah. Now it is moving, right? So
Yes,
you
sir.
can see my slide.
Yes, sir.
So there are different type of disasters are there. One is called a natural disaster, which is happening naturally. Okay, it includes drought, earthquake, tsunamis, forest fires, landslides, and mudslides, blizzard, hurricane, tornadoes, floods, and volcanic disruptions. So these are all happening without any of our influence. Okay, it is happening naturally. Okay, it is not controlled by us, we cannot control this. But there are certain disasters happening due to human being, that is includes hazardous substance accident, for example chemicals and toxic gases emission, radiological accident, dam failure, resource shortage, example food, electricity and water, structural fire and explosions, and domestic disturbances like terrorism, bombing, and riots, bioterrorism, explosions, like that. So these are all some of the things created by the man. That's why it is called a man-made disaster. Okay, so these are all the type of disasters. The fire, toxic material pollution, civil unrest also falling in this category. Sometimes we can also find the mixed, both natural as well as man-made disaster also. Okay, so generally the major natural disasters are we also come across this flood, cyclone, drought, and earthquake. So most of the natural disasters are related to civil engineering, because due to this most of our civil infrastructure are getting damaged. Okay, so but the minor natural disasters, we can say this cold wave. So during this winter we are facing in North India, and thunderstorms, that is related to the rainy season, heat waves at the summer season, and mudslides, some of the hilly terrains and other places also we are facing this problem. These are all some of the minor natural disasters. And major man-made disasters, we can say the setting of fires. Sometimes the forest fires also happening, some epidemic, like we recently we come across this COVID, and deforestation, pollution due to the prawn cultivation, chemical pollution, and the war. So now recently we are seeing there are a number of wars also going on, like between Russia and Ukraine, and other wars also. And there are some minor man-made disasters like road or train accident, riots. Every day we are hearing this news through the newspaper and TV channels. We are all watching this. And food poisoning, industrial disasters or crisis, environmental pollution. So these are all some of the minor man-made disasters. So like that we can categorize the disasters. So there are some certain principles for the disaster management. One is prevent the occurrence of the disaster whenever possible, because the consequence of the disaster is very severe. That's why we try to prevent the occurrence of the disaster whenever possible, wherever possible. Okay, So we have to minimize the number of casualties. If you have knowledge about the disaster, how we can mitigate the problem, then we can minimize the casualties. Okay, so and also we can prevent the further casualties. Okay, once it is happened, how we can minimize the further casualties. So that's why this knowledge is very much important. We have to educate the people also. So if there is a disaster happen, how we can protect ourselves, how we can prevent the further casualties and all. And we have to go for the rescue of the victims, provide the first aid to the injured, evacuate the injured to medical facilities, and provide a definite medical care, promote reconstruction of the lives. So these are all the principles of the disaster management. So we have to follow these things as and when required. We have to follow one by one. Okay, so the disaster agent, actually the primary agent for a mainly the falling of buildings. So heat, wind, rising water, and smoke. These are the primary agent of the disaster. And what are the secondary agents? That is including the bacteria, viruses that produce contamination or infection after the primary agent. Because once there is a damage is happened, there is a possibility for the breeding of more bacteria and viruses. It can also spread more diseases and other things also. So that's why it is falling in the category of the secondary agents. Okay, and there are a number of environmental problems will also happen. For example, physical factors. So it includes weather conditions, availability of food, water. So we will face a lot of problems, like there is a scarcity of getting the food, getting a good quality of water. Otherwise there is a chance of mixing the good drinking water with the sewage water and other things. So and other thing, like there is a malfunctioning of the utilities, like very essential utilities like electricity, telephone services. So everything will disturb you like anything. So these are some of the physical factors. Apart from that, there are certain chemical factors, which includes leakage of the stored chemicals in the air, soil, and groundwater. Okay, so these are all some of the chemical factors. Some biological factors, which includes contaminated water, improper waste disposal, insect and rodent proliferation, improper food storage, and some social factors like contributing the individual social support system, loss of family members, because there are a number of people in a family, but there are certain people can survive and rest of people would have died. So that kind of problem will also there. Changes in the roles and the religious beliefs. So there are a number of problems associated with this society. And psychological factors, like people will get distress. Okay, so due to the disaster, so there are a number of problems involved in this category. Okay, so what are the phases of the disaster? If you talk about the phases, there is a pre-impact phase, that is a initial phase of the disaster. So the warning should be given to the actual occurrence. So the emergency centers are open, and we should have proper communication through radio, television. We have to educate the community. Okay, that's what we have to do in the pre-impact phase. Then the impact phase, what we have to do, we have to continue the threat of the further destruction. Okay, this should be possible to the people, and we should operate the emergency operation center. Okay, and we need to provide the physical and psychological support also for the victims. So in this way we can minimize the damages. Okay, and post impact phase, here what we have to do, recovery being done in the from the emergency phase, and also we have to return the normal community. Okay, and also we have to evacuate the people from the impacted area. Okay, for example, the victims of the atomic bombing of Hiroshima, there and all they have done it. So similar kind of thing we have to do in case of the disaster. So what is disaster management? So quite often we are hearing this term. Actually, what it consists of? You can look at the picture. So here it is clearly
Sir.
mentioned.
Sir, could you please switch on your presentation mode, sir? Slides are not moving.
Oh, sorry.
Presentation mode, then it might be working.
Okay. Don't know what happened. There is no option.
Could you please hit on F5, sir?
Yep. Actually, it is showing presentation mode only for me.
Yeah, now it's okay, sir. Now it's okay. Could you please move slides, sir?
Okay.
Could you please move slides?
Yeah. Yeah, I'm moving, but you are not able to see.
Yeah, sir. Sir, could you please, Yogi, are you there? Sir, now it's moving. Could you please move?
Moving?
Yes, sir.
No.
Yogi.
Moving or not?
Only one slide has been moved, sir.
I don't know. Maybe I
Yogi,
will
are you
again
there?
rejoin otherwise.
Sir, now please move another slide from 15 to 16.
15 to 16. Otherwise, I will rejoin it again. Okay.
No, sir. Please wait, sir. Yogi, are you there? Sir, 1 minute. If sir, you please continue, sir. I will ask to share another screen.
Okay. Are you
they need
able
to
to see?
share a window. Sir, could you please share your window, complete window, entire screen?
Okay. I stop presenting again. I will do.
You need to stop the sharing and now share your entire screen, sir, instead of a tab.
Okay. Now you can able to see.
Yeah, now it's sir. Could now you need to open your presentation, sir. Now please hit on F5, sir. Presentation mode. Yeah, could you please slide 1 or 2 slides, sir?
Now I am moving. You
Yeah,
can able to see?
yeah. It fixed, sir. Thank you very much. Sorry for the inconvenience, sir.
Okay. No issue because after a long time we are doing on online. That's why. Okay, it's no issue. So quite often we are discussing about the disaster management. So you can see the right side picture. So here it is shown what it consists of. Actually, first we should have a preparedness. So the preparedness means the activities prior to the disaster. For example, preparedness plan, emergency exercises or training, warning systems. So these are all falling in the category of preparedness. Then we have to respond. So like during the activities during a disaster, public warning system we have to do, emergency operations, and we have to do the search and rescue of the people and other things also we have to do. Then we have to move for the recovery. So in the recovery, actually, for example, we have to make some temporary housings, claims processing and grants, long-term medical care and counseling, and we have to do the mitigation also. That is activities that reduce the effect of a disaster. Okay, so these are the things we have to do. Just read it. Yeah, the building codes, zoning, vulnerability analysis. Okay, these are all falling in the category of mitigation. Okay, so the disaster management consists of all these things: preparedness, response, recovery, and mitigation. So these are the steps involving in the. For example, here you can see there is a collapse of the bridge. It may happen due to the earthquake. Okay, the same thing I have told already. Okay, so this I am skipping. So the role of preparedness. So what is the role in the preparedness within the employing organization? We have to help initiate or update the disaster plan, provide the educational programs and a material regarding a disaster specific to the area, and organize the disaster drills. So these are the things we have to do. Then under the community health nurse, actually what we have to do, we have to provide an updated record of vulnerable population within the community, and leader where an intimate knowledge of the institution or familiarity within the individuals who work there, so he can give the idea about the disaster, and we can make a awakening of people also. As a community advocate also can play a role, and other people also, those who are working in the team like Red Cross, Salvation Army, or emergency medical system, ambulance. So everybody should involve. That's how we can able to do the preparedness. And in case of response, so what we have to do, we have to do the some shelter management. Okay, by getting the help of the local Red Cross buildings, and we have to make some tent and other things also to ship the people, those who are affected. For them, we have to make some tent arrangement also. Assessing and referring also we have to do. So we have to keep some records, and we have to give provide a first aid. We have to provide the meals and all the amenities we have to provide. So, okay, and if necessary, we have to arrange some communication and transportation also. We have to provide, and we have to make the environment as safe as possible. Okay, so sometimes the international relief efforts will also be implemented. For example, the Red Cross and the Red Crescent Society can also involve along with the WHO. And sometimes we need to provide the psychological stress release also. For example, we have to give a kind of counseling the people, those who are affected by the disaster. Okay, so we have to give some counseling also. Sometimes we have to look at the environmental factors, for example, noise, inadequate workspace, physical damage, danger, and stimulus overload, and other things also we have to see. Okay, so all these things fall in this category. And how we can do the disaster recovery. So what we can do, we have to do the community cleanup efforts and release the continuing thread, and teaching about the proper hygiene, how we can make it sure there is no further damage happen. So we have to educate them also. And sometimes we have to give the psychological support. It should be short term, and we need to give some alert about the environmental health hazards. And sometimes we need to go home to home visit, and we have to make awareness, and we have to educate the people also. These are the things we have to do. Then mitigation. So how we can do the mitigation. So working with the local, state, and federal agencies to identify the disaster risk, and developing the disaster prevention strategies. This way also we can give proper education to prevent and also we can make the people be ready to face the problem. Okay, and we have to plan effectively for the disaster prevention. Okay, we can provide information including the knowledge of community resources like emergency services, hospitals and clinics, community health personnel, and community government officials and local industry. So these are the informations we can provide. So generally, the disaster management committee should consist of following things. One is the chairman, medical superintendent or director, additional medical superintendent, nursing superintendent or chief nursing officer, chief medical officer in case of casualty, head of the department. It includes surgery, medicine, orthopedics, radiology, anesthesiology, neurosurgery, and then we have to arrange the blood bank in charge, security officers, transport officers, sanitary personnel. So all these things actually constituting the disaster management committee. So everybody has to play their role. Okay, and the multidisciplinary disaster management team should consist of the following people. It should have physician, surgeon, orthopedics, nurses, fire service, police, politician, safety officer, chaplains, NGOs, multidisciplinary team, paraprofessional, psychologist, social worker. Also, all these people should constitute this multidisciplinary disaster management, and they have to give the immediate attention whenever the people are in affected in the disaster due to the disaster. We have to pay proper attention. And quality of nurse working in the disaster is very important. Actually, their role is very much needed also. Okay, so all these activities they have to do, because I don't want to cover all these things, because I mainly going to focus on civil engineering aspect. So these are the things one can go through that. Okay, I am not going to talk about this nursing of disasters. Only thing this already we have discussed. Role of nurse in disaster mitigation, what they have to do, that is given over here. Okay, okay, this I am skipping. Okay, straight away I will move to the role of civil engineers. What is the role? Because most of the damages are happening for the civil infrastructure. So that's why I am going to focus more on civil infrastructure. What are the things are happening, how we can minimize the damages happening on civil infrastructure, so that we can see. Okay, what we can do, role of rehabilitation and reconstruction phase. Okay, so what we can do here, so we can have a proper surveillance and prevent some of the epidemic outbreak, because due to these damages, there is a chance of getting the epidemic outbreak also, like the viruses and bacteria can also spread, and it can create a lot of problem. So that's why we need to have a proper surveillance, and we need to provide a good quality water supply. The potable water should be not having any contamination, that we have to ensure, and food supply should be proper, and we have to make sure the safety of the affected peoples, and control of vectors, and care of survivors, and if necessary we need to give the proper vaccination also. In this way, further damage we can reduce, and the victims need some counseling also, that we have to provide, and behavior modification also we have to see, and we have to go for the reconstruction, like setting up of shelters. So most of the people lost their shelter, so we have to provide some temporary shelter, and gradually we have to equip with all the facilities, at least essential facilities we have to provide. So health, food, and other facilities also we have to provide in that campus. And if the rehabilitation it takes more time, then we have to give proper education also. So, and we need to training the people through the students, volunteers, we can do this also. And also we have to take care about the mental wellness. So in any major disaster, people want to know whether the loved ones are there or not, like that, because there are certain people will be scattered, they cannot able to know their near and dear will be available or existing or not, they may not be knowing. That's why they will be big agony. So we have to have a proper counseling we have to give. So in case of loss, people need to mourn. So then what we have to do, we have to give them space, let them mourn. Okay, so find the family, friends, or local healers to encourage and support. So most are back to normal within 2 weeks. Generally, it used to happen. About 1% to 3% may need additional help. So little attention is paid to the children. So because children's they are becoming destitute, then we need to pay more attention also. Listen attentively to the children without denying their feelings. So that we have to do. So give easy to understand answers to the questions. In the shelter, create an environment in which children can feel safe and secure. So like we have to make some play area under in this way, so we can make them more comfortable. Okay, so and we have to categorizing the damages also, like there are different coloring, like red color, that is most urgent, first priority. Yellow color means it is urgent, second priority. Green means third priority. So black means dying or dead. So like that we have to categorize the damages also. Accordingly we have to pay attention, and where we have to give the first priority, second, that and all we have to choose. Okay, who decides the triage or the priority? So the nurses. Okay, so don't act for a legal fears of being blamed or death. So lack of clarity. So okay, so in that case it will be very difficult. Okay, so nurses function to the level of their training and experience. If nurses they are most trained person at the side, they should be in charge. In this way they can decide the triage means the priority. So the first priority, that and all they can decide, and accordingly they can do. Okay, so the red and most urgent is first priority, as I told you earlier, that we have to give. uh, and yellow already I discussed, yellow and other color also I have discussed. So the block means that is nearly people have died, that category. And there is coordination and involvement of the community is required, because there should be having a proper yeah. Hello, am I audible?
Yes, sir, you are
Hello.
audible. You are
Okay,
audible.
okay. So we should have proper psychological care, emotional support services, and treatment for victims and their families also we have to give. Okay, and we have to make sure the access to the community also. Is there the current community disaster plan in place or not, that we have to check. What previous disaster experiences has the community been involved with locally, statewide, or nationally, that also they should have the access. And how is the local climate conducive to disaster formation? How is the local terrain conducive to disaster formation? What are the local industries? So all this kind of information we should provide also. Are there any community hazards are there, that also we have to check it. Okay, and we need to have a community disaster planning also. So develop a disaster plan to prevent or deal with the identified disaster threat, identify a local community communication system, and we have to identify the disaster personnel, including private, professional, volunteers, and local emergency person also we have to do. Okay, and we have to implement the disaster plan. So here what we have to do, focus on primary prevention activities to prevent occurrence of a man-made disaster. Practice community disaster plans with all personnel carrying out their previously identified responsibilities. Practice using equipment, obtaining and distributing supplies, evaluate effectiveness of the disaster plan, critically evaluate all aspects of the disaster plan, and practice drills for speed, effectiveness, gaps, and revisions. Evaluate the disaster impact on community and surrounding regions. Evaluate response of personnel involved in a disaster relief efforts. So these are the things we have to implement in the disaster plan. Okay, and in case of the rehabilitation of, by health sector, so they have to do the community cleanup efforts, teaching proper hygiene, alert for environmental health hazard, home visits, and follow-up care also they have to do. Okay, so mostly what is happening due to the this disaster, for example, here you can see the mortality used to increase. So you can see over the period of time, so there is a increase in mortality is happening for different disasters. They have shown this picture: earthquake, epidemics, extreme temperature, flood, landslide, storm, and others. As I told you earlier, there is a statistics around 30 lakhs people who died over the past 20 years due to this disaster. That's why we need to educate the people. If there is a disaster happens, then how we can minimize the damage. We should know the mitigation idea. That's why it is very much needed. This knowledge should be disseminated to each and every person. Okay, so the average annual impact from the natural hazards are shown here. The mortality rate and the crop area and the property, everything is shown here. There are a lot of damages happening due to the natural hazards. So we are all seeing these kind of things every day in the newspaper and other things. So somewhere something is happening, and disasters. Okay, so a lot of agriculture fields also affected by the natural hazards. Okay, so okay, here you can see the wind and cyclone hazard map of India. So there are a lot of problems are happening. Cyclone is quite often happening. So every time we are hearing this, so somewhere in India is always happening due to the rainy season. So we are getting the cyclone hazards. So due to that, lot of crab and other living beings also affected by this cyclone. Okay, and road hazard. So that is another thing. So somewhere the road accident or train accidents are happening. So that is also this is a man-made disaster that actually we can prevent also. If you are doing proper driving and other things and all this, we can up to certain extent we can avoid this also. We can minimize this road hazard and all. Okay, so if there is a disaster happens, then who are the nodal ministries? So this knowledge also we should have. For example, there is a natural disaster is happening. For example, the cyclone, flood and all happening. Then who is a nodal ministry? Is the agricultural ministry. Air accidents are happening, then civil aviation ministry. Civil strikes are happening, then it is a home affairs. Railway accidents, railway. Chemical disaster are happening, then environmental ministry is responsible. Okay, the biological disaster, the health and family welfare. Nuclear accident, then the atomic energy ministry is a nodal ministry. So they have to take care and they have to do all kind of activities to minimize the damages. Okay, the national response mechanisms like this. So the union cabinet having the division like a national crisis management committee and agriculture ministry. Then there is a secretary, agricultural secretary. Under him there is a state relief commissioners, central relief commissioner, and again Indian meteorological department, Central Water Commission, and other department will are coming. Then finally, the crisis management group will be there. So like that, they have categorized. The national response mechanism is working like this manner. Okay, and the management mechanism actually there is a integrated administrative machinery, national contingency action plan to identify the initiatives by various agencies. The Department of Agriculture and Cooperation, the nodal department, and a central relief commissioner, chief nodal officer at the national level, and state or district contingency plans and relief manuals. All the things are available for the management mechanism. These are all the things are ready-madely available already. It is well established. Okay, and in case of the natural disaster response, so the government of India having this National Crisis Management Committee, that is shortly calling as NCMC, under the cabinet secretary, and there is one more that is a crisis management group, that is shortly called as CMG, under the central relief commissioner. Then a group of ministers, group of secretaries, high level committees at the need based level they are creating. Okay, and there is a department of disaster response, like armed forces, Ministry of Defense, central paramilitary forces, Ministry of Home Affairs, and international responses, Ministry of External Affairs. So all will play their role. In this way they can mitigate the damages and they can minimize also. And in case of the department disaster response, so the ministries or department consist of the rural development, drinking water supply, power, telecom, health, urban development, food and public distribution, shipping, surface transport, railway, civil aviation, women and child development, water resources, animal husbandry, Indian meteorological department. All the people are jointly involving in the to whenever there is a disaster happening, then they are coordinating the things and they are trying to minimize the damage level. Okay, and disaster management policy having the following salient features. One is a recognition of the linkage between the natural disaster and development. The next, connecting of the specific program. Okay, there are certain programs they have mentioned, so that they are having a coordination, and they should give emphasis on forecasting and warning using the advanced technology, like our meteorological department is doing. So whenever there is a cyclone is happening, they are telling. So now the cyclone is formed, the depression is formed, it is moving this direction, it is going to give a heavy rainfall for certain duration. So people should be careful, and the downstream people should be evacuated. So like those kind of the warning also given by the meteorological department. Okay, and central sector schemes also available, like human resource development, setting up of National Center for Disaster Management, that is called the NCDM, and then setting up of disaster management faculties in states, and a program for community participation and public awareness, observing the national disaster reduction day, activities to achieve the goals and objectives. So a number of programs are available. So the disaster management, actually this way it is a very effective manner they are implementing, but the only thing is the knowledge should be disseminated to each and everybody. Okay, and if there is a external assistance is okay, then no formal appeal for the external assistance made for relief. So external assistance, if offered as solidarity, accepted with the gratitude. For example, Gujarat earthquake, the international response was overwhelming. So the bilateral agreements suggested by some countries for emergency response. So whenever something happening, the international community also coming forward to help us. We also reciprocating whenever something is happening in abroad. So we are also extending. We are also sending our relief materials and other things. Sometimes we are sending our rescue team also, the foreign countries also. So these kind of things should be highly encouraged also. And disaster response arrangement in the states. So state level also they should have some committee, like it consists of the state cabinet, the state crisis management group headed by the chief secretary, and institution of the relief commissioner in the states, and they can have some district level plan also. Okay, district contingency plans and relief codes also they can keep. So these are all some of the things they should establish and they have to maintain also. For example, the Andhra Pradesh cyclone hazard mitigation project. So they have come across this kind of outcomes. Hazard mitigation studies, they have done it. IMD, early warning capacity through the Doppler radar, and infrastructure creation, restoration, flood and drain embankment, road restoration, storm shelter, electricity transmission and distribution, and all kind of things they can provide also if they are having a proper management. Okay, and following observation also they can do. For example, recognition of the linkage between the natural hazard and development, and connecting the development programs to disaster management, forecasting and warning. So latest technology we have to use. Okay. And contingency planning also, like food grain availability, preparedness. So adaptive capacity by creating a management system. So all the things we can do. Okay. So there are certain questions will also rise, like how can we evaluate the portfolio of disaster management project? So we need to assess the implication of the climate changes for project the benefits, and we have to assess the implication of the project for reducing the vulnerability. And some other related questions will also arise, like how can we incrementally adjust the project design or implementation to enhance climate change related benefits. So these are some of the things need to be answered. Okay. So what will happen if the disaster happens? Should we worry about the disaster? There are a number of disaster happening in different continents. So there are some top 10 countries also shown here. So the statistics is shown. This is taken from the source of CRED 2021. Okay. So the occurrence of disaster by type 2021 compared to 2001 to 2020 annual average they have shown. So maximum disasters are happening in Asia, and in Asia particularly, so highest is happening in India, 19 they have given 19. The next is China, then Philippines also having big number. I think among these Indonesia has the highest number. In America also having more disasters. Okay. So and other South American countries also they have shown here in this picture. So nearly we need to worry, because we should have preparedness. Otherwise, there is a lot of damage will happen. Okay. So there are the share of death also they have shown here. It's okay. In this picture, you can see if you are having a proper disaster mitigation, then we can minimize the casualty also. So that's why we should worry. Okay. So over the period of time, we are reducing the damages as well as the casualty also we are reducing, because how to behave during the disaster, that kind of knowledge we are gradually gaining. Okay. So that's how we are reducing the casualty and other damages also we are keep on reducing also. Okay. So and there are a lot of economic loss also happening. Okay. So that also over the period of time we can reduce it if you are having a proper knowledge and a proper mitigation strategy. So we can reduce it. Since 2001 in India, the economic losses due to the disaster are rupees 13 lakhs crore, or 6% of the GDP. So according to the SBI, so this much happening. So that also we have to minimize it. So that's why this knowledge about the disaster management you should have. Okay. And cost of inaction, so that will also leads to more damages. So okay, so that we have to minimize it. And can we do something? Yeah, definitely we have to do something to invest something more in the disaster mitigation program. In this way we can minimize the damages. So we have to do that. Okay. So what is a disaster risk? So actually, to understand the disaster, we must understand what is disaster risk. Disaster risk is we can explore in a few terms, like hazard, exposure, vulnerability, coping capacity. If you know these things, in this way we can able to understand what is the disaster risk. Okay. So hazard, what does it mean? So a process, phenomenon, or human activity that may cause loss of life, injury, or other health impact, or property damage, social and economic disruption, or environmental degradation, generally we can say is a hazard. Okay. And what cascading or compounding of hazard may often happen. Okay. So the mainly the natural hazard triggering the technological stress. Okay. So what we can do, we should have proper knowledge, and we have to try to minimize the hazard damages also. For example, the situation of people, the infrastructure, housing, production capacity, and other tangible human assets located in hazard prone areas we have to minimize. For example, seashore infrastructures. So during the tsunami or a cyclone, there is a chance of getting more and more damage in the seashore areas. There is a damage may happen, and there is more vulnerable. These are all the most. If you build your house in an area which is prone to flood or earthquake, you are vulnerable. Let's say that you have built your house no matter what. But if you have not taken any measure to deal with it, then you are more vulnerable. So that's why we should understand the vulnerability also. So that is one of the important thing. Okay. And coping capacity, that is nothing but the ability of the people, the organization and system using the available skills and resources to manage the adverse conditions, risk or disaster. So the capacity to cope requires continuing awareness, resources and good management, both in normal time as well as during disasters or adverse conditions. Okay, if you have a capacity to deal with the disaster risk, you are good to go, else it is a disaster. Okay, so that's why we should know what is the problem going to happen, then we can able to minimize it also. So the disaster risk can be uh, proportional to the hazard and exposure vulnerability divided by the coping capacity. So this way we can able to calculate what is the disaster risk also. So there is a potential loss of life, injury or a destroyed or damaged asset which could occur to a system, society or a community in a specific period of time. Okay, this way we can calculate what is the disaster risk. Okay, and so this already we have seen what is the disaster we have seen. So now we can see some major hazards in India and Gujarat. So earthquake. So earthquake is one of the major disaster. Quite often we are hearing and we are watching in the TVs and newspapers. We are seeing this also. It says seismic hazards are responsible for an average direct death toll of over 20,000 people per year. Okay, this is according to only statistics. Okay, and there is a direct economic losses to the nominal GDP. For example, here the earthquake of Guatemala, that is 98 percentage economic losses, and Nicaragua 82 percentage, Salvador 40%, Haiti 120 percentage. So there is a huge economic losses also happening due to this earthquake disaster. Okay, and if you are talking about earthquake, we should know we certain terminologies. What is focus or hypocenter? Hypocenter means the point under where the earthquake is originating, that is hypocenter. Epicenter means the from where the earthquake is originated at the surface level, that is called the epicenter. And there are two waves actually causing the earthquake. One is called the body waves and surface waves. And what is the magnitude? Quite often they are talking about in Richter scale. So if suppose the earthquake is happening with certain Richter scale, again how long the duration is there, that intensity. And seismography is there is actually measuring the the ground motion. Okay, that graph will give you the ground motion, how much it is happening, that are giving the idea. That's why we should have some knowledge, then only we can able to understand how big earthquake is happening, how long duration is happening. So this kind of knowledge if you have, then only you can able to get some idea. Okay, so and the magnitude and the intensity also we should know. What is the magnitude, what is the intensity, that they have explained through this picture also. Okay, so the magnitude is a quantitative measure of the actual size of the earthquake, whereas intensity is a qualitative measure. That's the difference between the magnitude and intensity. That's how we can able to differentiate the magnitude and intensity also. This is the earthquake hazard map of India, because we have categorized zone 2, zone 3, zone 4 and zone 5 like that. So, okay, the zone 5 is a very high damage risk zone. Okay, and zone 2 is a low damage risk zone. So this way we can able to see the different part of India. So where we are falling under, we can able to see. Okay, and again it's a earthquake hazard map of India only. And there are certain case studies about Gujarat earthquake. Okay, so the Gujarat earthquake, that 2006, I think 2001, yeah. So it happened. This earthquake magnitude is 6.9 on Richter scale. The epicenter were Chabori village, north Kutch. 21 out of 28 districts are affected. One of the worst earthquake in the last 180 years. Over 10 million people are affected by this, and 7,633 villages are adversely affected, and 450 villages are flattened totally. So the reported live loss is 13,805, and there are around 1,67,000 persons have suffered with injury, and a lot of houses also lost, completely destroyed. Okay, and certain houses also damaged, and there are certain buildings like police department, admin buildings, also destroyed. Residential buildings, number of residential buildings, and over 300 hospitals also destroyed. Around 5 million people needed to be given immediate relief all over the state. So okay, it's a very big task, because suddenly if happens, then how to manage this thing. So that's why we should have a proper disaster management team. They would have trained properly, so then only they can able to handle this. Otherwise it will be very difficult to handle, because at a time they need more attention also. We should have proper manpower and proper management, then only we can minimize the further damages. Okay, so what they have done in 2001, what is the damage assessment, or they have done it. So they have done some direct assessment, okay, and some indirect assessment and tertiary assessment also. They have done it, and the direct assessment, they have counted the human lives, how many people died, how many livestock and other animals are died, private property damages, municipal infrastructure, and our telecommunication damages, health and education asset. So all the things they have calculated. This estimate is around 9,900 crores. And in case of indirect assessment, there are certain things they have done, like how the export import is affected, agriculture output, how it is affected, industry services, remittance income, falling earning, and unemployment, health hazard. All the things are costing around 3,000 crores. Whereas in case of tertiary, there is some long-term development, like overall investment, climate is affected, fund reallocation they have to do, community migration and relocation. So this is cost around 10,100 crores. So these are all the things also they have done it due to this Gujarat earthquake. So they have done this. Another problem is cyclone. So one of the biggest thing is happening. Quite often we are facing this. Out of 8,000-kilometer coastline, so Gujarat is having the highest long coastline it is having. Okay, it's close to 5,700 kilometer prone to cyclone. So quite often Gujarat is getting more cyclone problem also. So here we can get some idea about the cyclone category, how one can categorize the cyclone. Super cyclonic storm means the wind speeds should be more than or equal to 221 kilometer per hour. Otherwise you can say more than 120 knots. So knot is another unit one can use. Okay, if extremely severe cyclonic storm is generally categorized if the wind speed is in the range of 166 to 220 kilometer per hour. Very severe cyclonic storm is in the range from 118 to 165. So like they have categorized, there are different things. Okay, simply depression means it is having the speed around 31 to 50 kilometer per hour. So these are all the things give idea about the severity of the cyclone. Okay, this is the cyclone hazard map of India. So we can see there are different coastal states used to get more and more cyclone problem also during this rainy season, and particularly in the monsoon season we are all facing a lot of problem due to the cyclone. The earthquake is the biggest thing. Next, cyclone also equally giving more damage. Okay, that's how they are giving this wind hazard map as well. Okay, and so again it is the detail related to the Gujarat state. I am skipping this. And another thing is tsunami. The tsunami must be treated as a multidisciplinary hazard, because they can be triggered by earthquake, landslide, or volcanoes or meteorological events. So with a large earthquake being the most trigger. So this is another biggest disaster. So this also giving a lot of damages for the men and materials and livestock. Everything is getting affected by this. Okay, uh, so mostly how it is happening, this rupture in the sea floor pushes water upwards, starting the wave, and a wave moves rapidly in deep ocean, reaching a speeds up to 500 kilometer per hour. As the wave nears the land, it slows to about 45 kilometer per hour, but is squeezed upward, increasing the height. So the wave hits island, destroying all its path. So that's how the tsunami is happening. And you can see the most prone tsunami prone area is Java Sumatra area. So these are all the areas very prone to tsunami. So quite often we are hearing this. These areas are getting more and more tsunami. Sometimes we are also facing this problem. Okay, so sometimes it is also affecting the state of Gujarat also. So and a flood. So flood is the biggest thing. So quite often we are hearing this news because we are not having a proper drainage system. That is also one of the thing, because the cities are developed without any proper plan. So that's why most of the metro cities are quite often they are facing the flood condition, because they're without any knowledge, they're simply closing the lake and bonds, and they are creating the real estate. That's how it is creating a huge problem. So in Singapore, actually, I am having experience because they are having a rainforest climate. 6 months it used to get a rain, but you cannot find a rainwater in the roads. All the water will drain off immediately. So they are having a proper drainage system. So that kind of thing we have to have. So proper planning is required. That's where we are lagging. That's why whenever there is a heavy rain is happening, we are having the flood condition. So this one can avoid if you are having a proper planning of a drainage system. Then if you are having a proper canal system, so the water should be drained out. Okay, so that kind of thing we can do. Otherwise, we have to face the problem. Okay, so there are flood also. We are getting some urban flood, sometimes flash flood. So all these problems are also happening. Okay, so most of our metro cities are having this problem. Year by year, we are all hearing this news because they are not having a proper drainage system. It's not planned properly. So that's why we are all facing this flood condition. So the Gujarat also one of the state quite often they are getting the flood. Particularly the Banaskantha district is quite often getting more flood situation. Okay, so and we are also facing a problem, heat wave. So nowadays, due to the global warming, the temperature is keep on increases also. So that's why the heat waves and the temperature soaring also happening in the summer, as we are all experiencing year by year. The temperature keep on increases also. So there is another problem we are facing. The maximum temperature of any place continues to be more than 48 degree for 2 days. Then there is a heavy problem will be there, because the 48 degrees Celsius temperature and all very high. Only in Gulf region, only people used to have this much heat. But now in summer, we are also having this kind of problem. Okay, this is also happening due to the global warming. This is one of the climate change is happening, and some other technological hazards also happening. Particularly, I am talking about Gujarat, as I belongs to the Gujarat. That's why I am giving more detail about the Gujarat. So there are around registered factories. They are having more numbers, and major accident hazards also happening due to the factories. Uh, so this also one can minimize if you are having a proper knowledge and a proper mitigation plan. Then we can minimize these technological hazards. We can minimize. Okay, so and we are here and where we have to move. That's what I have shown here. So okay, disaster management and disaster response is required. So actually from this we have to go risk prevention, living with uncertainty. So these are ways we can do this. Okay, so this is very much needed to minimize the damages. Okay, and prevention is better than cure. We know the proverb, prevention is better than cure. So it measures the objective of which is to avoid the occurrence of disaster. Prevention. So mitigation is it's a measure aimed at reducing the impact or effect of disaster. So then you have to go for the preparedness, like set of readiness. Okay, response. Measures taken during or immediate after the declaration of the disaster. Okay, that is the response. And recovery. So we should recover the actions taken by the community and all the government and non-government agencies supporting. Okay, so these are all some of the management we have to do. Okay, this is the disaster management cycle, and this is the Sendai framework for disaster risk reduction. Okay, it's a latest framework for DRM. That is it is outcome of the third World Conference of the Disaster Risk Reduction. So they have kept 7 targets. That is disaster mortality should be reduced by 2030, and number of affected people should be reduced by 2030. Economic loss also we have to reduce as much as possible, and infrastructure damages we have to reduce, and DRR national or local strategies by 2020, and international cooperation by 20. Like there are number of things they have made it. So there are certain policy they have made it. So first, what we have to give the priorities, like understanding the disaster risk, and strengthening the disaster risk governance to manage the disaster risk, and investing in the disaster risk reduction for the resilience. And we have to enhance the disaster preparedness for the effective response. So these are the things we have to do. Okay, so in this way we can minimize all the damages. Okay, so okay, these are some of the management plans we can do. Okay, so one can do this development can increase the development activities, can increase the damages. Okay, so the vulnerability can be reduced. Okay, development can reduce the vulnerability. Whatever the development we are doing, it has to reduce the vulnerability. And disaster can provide development opportunity also. That is a positive realm. Okay, from negative to positive we have to move. That's what we have to do. Okay, so we need to do development. At the same time, it should not damage. We should go with the sustainable development. Sustainable development is very much needed because sustainable development can ensure there is no damage to our environment. Okay, so in this way we have to, wherever possible, we have to adopt the sustainable management and sustainable development goals we have to keep. That is, it should be economical, it should not make any environmental impact, and it should be beneficial to the society. So these are all things we should keep in mind, and accordingly we have to move forward. Okay, so even our honorable prime minister have 10-point agenda for this. So all the development sector must imbibe the principle of disaster risk management. Risk coverage must include all starting from poor household to SMEs to multinational corporation to national state. Women's leadership and greater involvement should be central to disaster risk management. Invest in risk mapping globally to improve the global understanding of nature and disaster risk. Leverage technology to enhance the efficiency of disaster risk management efforts. Develop a network of universities to work on disaster related issues. Utilize the opportunities to provide by social media and mobile technologies for disaster risk reduction. Built on local capacity and initiative to enhance disaster risk reduction. Make use of every opportunity to learn from disasters, and to achieve that there must be studies on the lessons after every disaster. Bring about greater cohesion in international response to disaster.
Hello.
రఘు సార్ ఆడియో రావట్లేదు.
అదే సార్. ప్రొఫెసర్ విన్నాం సార్.
Hello.
సార్ అగ్నిహోత్రి సార్, నమస్కార్ సార్.
Hi. Yes. Okay. I am
Sir.
here. Good evening, everybody. Okay.
గుడ్ ఈవినింగ్ సార్.
Okay. Just okay, please. Please, Raghu Babu, please. You want to say something?
సార్ ఎస్ సార్. శశిధర్ సార్. హలో.
Yeah, Raghu.
Sir, is anyone there to brief Agnihotri?
Raghu. Shall I introduce the sir?
Yes,
Hello.
sir. Yes, sir. Sir, Professor Shridhar sir, over to you, sir. Please introduce Professor Agnihotri.
Sir, namaskar, sir. Thank you very much for accepting our invitation and being a speaker, sir. So, my dear participants,
The next speaker of today's session is Professor P.G. Agnihotri, sir. He is a professor in SUNIT Surat. Sir has done his PhD from SU Institute of Technology, Surat. He is having vast experience. Presently, he is a professor. Former, he was a Dean Faculty Welfare, former Associate Dean Faculty Welfare, former CPIO, RTISL. At present, he is a professor in charge in training and placement. He is having 31 years in teaching, research and consultancy works. Sir, areas of interest are water resources engineering, flood mitigation and management, surveying, application of geospatial technologies like GIS, GPS, remote sensing. He has guided 32 MTech projects and 5 PhDs completed and 11 is ongoing. And presently, yes, he's having 49 international journals, 31 international conferences, 12 book chapters, 3 national journals and conferences. He has a consultancy services of more than 50 lakhs. He's having research projects in collaboration with Space Application Center, ISRO, Government of India, Ahmedabad. Almost he has delivered 18 lectures. Is playing a major role in SUNIT Nagpur. I hope we'll have a wonderful session. So now over to you, sir. Thank you very much once again for accepting our invitation and giving your valuable time, sir. Thank you very much. Over to you, sir.
Okay, thank you, Professor Sasidhar. Thanks for the kind word. Thank you to Dr. Raghu Babu also. Just I am having the session or the speech on water resources and flood mitigation. Yes, this is my, what you can say, the very nearest and dearest topic. Just I will sharing my okay. FDP just no, okay.
Sir, do you have sharing option, sir?
Okay. I am just an entire screen.
Yes, sir. Entire screen. It might be better.
Entire screen. Okay.
Yeah, it's working, sir.
Yeah. Okay. Now
sir,
I will just make PPT is visible.
Yes, sir. Could you please hit on presentation mode, sir?
Yes. That I didn't.
Yeah. Could you please slide 1 or 2 slides, sir, to ensure whether it is working or not? Yes, sir. It's working well. Thank you. Thank you very much, sir. Thank you very much.
Okay. One more thing I want to present. Just this is the windows of ArcGIS. Is it displaying?
Yes, sir.
Okay.
Yes, sir. It's okay.
Interface is displaying.
All are visible, sir. No issue, sir.
Okay.
Screen is visible.
Okay, fine. So I will start with this. So good evening, everybody, and thanks to Professor Sasidhar and Raghu Babu to give me the opportunity to interact with this audience. So water resources management and flood mitigation. That is my, what you can say, the just I told you nearest and dearest subject, because there's the water, if you say, that is the very much important part of the life, and without water we cannot survive. And water, and if you will see anywhere, the water is just considered precious, and it is normally said by the people or the society that third world war will be for water. So this is a generous gift for the mother nature of all the living beings. Okay, and it is a very common example is that if you are thirsty and if somebody will give you either tea or cocoa or even any other cold drink, no, but water will required. Okay, so that is the water importance, and any nation wants to make progress in the real manner should always think about careful and plan use of natural resources of like water. Okay, like that there is another commodity or another element, air is also there, but we are not talking for that. So hydrological cycle, that is known to everybody, that it plays the important role from surface to atmosphere as a vapor, and once again it will come as a rain to the surface of earth, and this is the cyclic process. And the distribution of this rainfall is with respect to time, space, it is a variable, and it varies from place to place also and time to time also. But this rainfall, if it becomes excessive, uncontrollable, may happen sometimes, that will carry the overflow of a river or some inundation of a surrounding region of the river, and that is known as a flooding. So if flooding, actually if you will say the flood in Surat 2006, there was a big flood in Chennai, also flood was there, and in Assam also, and in Bihar, Kosi river, and there are so many, these floods are there. And the flood water, if you will see, if you will just by chance, if you will taste it, it is our normal water, or rainwater if you will take in container, that is considered as a pure water, and that water in the flood, it is going into the sea ultimately. So that is a wastage of water. So that's why here in water resources management, we are managing the things by recharging the groundwaters and other techniques, conserving the water. But if such type of big loss, if there is a water, and sometimes what happened, there is a scarcity of water, and even we are not getting the water single time, or in some cities of India once in a week or something like that, of course in extreme summer. And I think that South Africa, that city, just like Cape Town, that is declared as a no water city or something like that. Anyway, so ultimately I want to come on the topic of this flooding. Flood, that is a most or major important event. It is a natural event, and flood is a such event which is dangerous to each and every living things also, as well as it is for the non-living thing also. Okay, so that is when the flood level, that river carrying capacity is not taking or accommodating the water because of the high rain, heavy rainfall in a catchment, and when it is coming and it flows over bank, okay, and inundate the surrounding region, we can say the flood. It is a just normal definition. And normally during the our school days, we have studied that where the culture develops, that is surrounding the river. Okay, so that is a but natural that their settlements and that other things, they are vulnerable to the inundation if it is in a such type of river. So in many regions and countries, the flood are the most damaging phenomenon which affects social and economics of the population. So due to this, human survival, not only human survival, but it is the properties and other associated or related things, it should be saved or it should be preserved. Now for that, actually if we can say the flood control, so flood control word is not that much proper, because it is difficult. Okay, it is difficult if there is a flood is there, and if you are building the dam is just taking some capacity, if still it comes more, but naturally we have to release the water from the gates and spillways. So here, rather than the word we are using is this word, mitigation. So the meaning of mitigation, actually the mitigate means this word has a very meaning is very depthful and thoughtful. Okay, because here if you see the definitions, mitigation is to make or become milder, less severe, less rigorous, less painful, more bearable to relieve. Okay, so this is also attached with our life also. It is also socially also. Okay, just like there, if you can say that I don't know about the foreign countries, but now they are following our Sanatan Dharma and Hindu religion. Otherwise, शादी किया और 2 साल में different. So that here also that we have to, rather than that, we have to mitigate our life or our life problems. Okay, we will not talk on that philosophy. So what is the floodplain modeling? So that floodplain modeling is the things which we are able to avoid the flood, or how to control it, or how to make it less painful. So normally there are two types of flood mitigative measures: curative measures and preventive measures. Preventive measures are that measures where we have to stop the water, put in a reservoir, okay, and we releasing policy and other things are there. And curative measures means we have to release the water, and after this, how to manage this water. So what type of, if the released water from the dam, we have to divert. If there is a problem of channel sedimentations, then dredging, and so many things and other curative measures are there. Here, particularly in this topic, we will see the floodplain modeling. Okay, how, for floodplain modeling means, in a simple way, if the water is released from the dam, some amount, of course it is excessive amount which is not accommodated by the river, and it starts inundation, then this model will give us how much area will be inundated and how, with how much depth. That modeling I will explain you here using the geospatial technology. So this floodplain modeling, if as you say, it is for the basic urban planning, bridge and culvert, flood reduction measure, design of drainage ditches, storm sewers, okay, and so many items. These are just few I have narrated here. But the floodplain modeling in flood, because if you want to mitigate it, first of all, modeling is required. Here, my main tool, main theme is a GIS based theme is there. Now, normally when we want to analyze the floodplain, or we want to study the flood event, there is a three phases or three aspects: engineering experience, physical modeling, and numerical modeling. So what is this engineering experience? Okay, so that is nothing but it is the, what we can say, the some hydraulic structure, weir, some gates, openings, okay, and that is as per the flow or past history or the past record we are making. Maybe weir, maybe dam, okay. So just this is a engineering point of view, this we can do. Second thing, that is the physical modeling. Now this physical modeling is little bit, what I can say, it is difficult to uh, simulate, okay, because in early 90s and late 80s that physical modeling was there, or physical modeling concepts starts from that time. But that physical modeling, we have to create the exact similarity or simulation or condition as if it is prevailing in a field, okay. Just like you can say the empirical methods and rational methods, and sometimes the empirical methods fails. Whatever somebody that is given for flood, empirical method may not work, because that conditions will not be there now. If you have prepared the physical model 10 years before and now the situation is different. So but we can make it just as a small model, or we can make our Gary has in Gujarat, Vadodara, Gary has a river river Tapi and Ukai dam model is there. But this numerical modelings, so here there are so many things are there. Here modeling means prediction of flood, prediction of flood frequency. Then if the flood is or the water is released from the dam, then how much time will it reach to the downstream area? Okay, and there is so many things you can do here, and here you can apply along with this the theory of randomization with the record of 100 years or record of 50 years. Okay, whatever the record is there. So here some rare exception, numerical modeling with computer programming is the most appropriate method to perform floodplain hydraulic studies. So actually, particularly in this topic today, flood mitigation, that how to do that thing, or here rather than mitigation, we will discuss the things that is flood plain modeling or inundation of a floodplain, okay, or submergence of a floodplain. In that case, water is released from particular point. If the quantity of that water is x cumex, then some area of city is submerged. If the quantity of water released is y cumex, then what is other the area will submerge, maybe more, maybe less, maybe depth is more, depth is that things are there. So that is the main purpose of this modeling. Now here just this is the schematic diagram or conceptual diagram is there for the channel, or channel means river. This is the normal surface and these are the flood waves. So means the meaning is that during the history the flood has just inundated up to this much area or this much distance, and this is known as a floodplain zone. And in this floodplain zone we should not have any type of residential area or any type of, it is just kept open. It is the conceptual meaning is there, and normally that is decided on the basis of 100-year average return period of the flood. But now here my 2-3 students have also worked on this, that urbanization, okay, urbanization is very much needed, or at most it is the need of the today's time. But due to these urbanizations, it interacts with the flood event, or it interacts or it interrupts the flood or the natural water. How? And that we will not be discussing here, but that study is there. And urbanization should be in such a way that this, it should not be in conflict with the waterway. Okay, here now these are the what preventive and curative measures are there. So here these are the first one, just it is the dams resort, it is a preventive measure, it comes, and the release of water and the policy of release of water, other things are there. Now channel modification, diversion, or levees. So these three are channel modification, means river channel cross section, there is a problem of sediments. Okay, if you see any river and there are lots of works are going on, sediment transport and sediment load. So that sediment, just now recently we have one consultancy of a DU, where myself and other professor from the structure side, we have visited there for solving the problem of capital dredging at that that is in a sea. So that channel modification means you have to either increase the depth or increase the width. Normally increase the width may not be permitted due to some some local oppose or whatever it may, some structures may be there, but we have to remove the silt from the channel, river channel, and we can make the modifications and we can give the design. Another thing, that is the diversion. Diversion means from some particular junctions you have to divert the water towards another side. Okay, you split the flow so that the flow which is going the mainstream may not become overflow. But at the same time, when you are diverting the flow and where you are diverting the flow, that is also important, because it's not like that we are shifting our damage from one place to other place. No, but splitting in that way that it mitigates, it becomes less painful, or the flow velocity, flow quantity, and submergence depth is reduced. That is the meaning. And the levies means, if there is a, you will release the water, it will be levies, or it is known as a side wall, or it gabion, or it is also known as in our Gujarati pala system. Okay, that we have to construct on the bank of river so that water will retain into this. But in the 2006 flood in a Surat, in a Tapi river, that levees at northern side was broken, and there is a, sorry, on western side and the southern side they have to make the blast so that the all, otherwise all the west zone will be under the water. That was the situation. So river flood modeling using the GIS platform. Okay, so that will be now, actually the GIS is a very much important tool. It is not the baby of only civil engineer or water resources, but for every branch, every engineering work, every engineering project, it is there. So here the GIS approach and hydraulic model, we have used the HACRAS. Okay, so that GIS approach is used in developing this model. Now here in particularly in this lecture, we have divided our modeling work into 3 parts. Okay, sorry, just I am giving it to this. Pre-processing of data, model execution, post-processing, or visualization of result. This is the our step. Now here in these 3 steps, pre-processing of data and third post-processing, that will be done in ArcGIS, and model execution is done in HACRAS. Okay, but here nowadays this pre-processing, so pre-processing of data you can directly do in HACRAS. Okay, that is a HACRAS 6.0 or above then version. HACRAS is freely available software. And then model execution, but naturally we have to do in a HACRAS. But if we want to see our result, means how much area is inundated, how much area, water depth is there, that is the map or preparation of map or preparation of inundation map, this ArcGIS is required. Okay, so here the how, what is the requirement and what are the things. So that is the floodplain management, flood insurance determination. Okay, sometimes what happened, the the authority or the local authority, they will mark the marking of the water ke kahan tak aaya tha, okay, up to this much, that they are doing. And then ultimately local inquiry also they are making this thing. But if we want to make it correct, or rather correct the most probably true value, we have to do this modeling. So here the first is our computer PC with the high configuration, RAM, and storage capacity. Okay, whatever the configuration, so that it can be speedily work. Then ArcGIS software, HACRAS, and HACGeoras. Actually, this whatever the work you are doing of pre-processing in ArcGIS, okay, that pre-processing work is transferred to HACRAS, where HACGeoRAS is become as a bridge. After this, in the HACRAS, the hydraulic work, the flow data, the flow conditions, and hydraulic modeling you run, the results are once again given back to ArcGIS. That is also through the HACGeoRAS. Okay, and there are special formatted files are there. This is a HACRAS is the US Army Corps of Engineer, and it is freely available. Hydrologic Engineering Center River Analysis System. This is the regarding the software. Now, what the data required? Okay, if you want to study the data required is one is the image of the study or image of the area, DEM or TIN model of the area, LULC map, and one more important is flow conditions, upstream boundary conditions, downstream boundary conditions. Okay, so here I will just explain you the things that image or aerial photograph or whatever the available or it is with you, you can use it. This is a DEM or TIN model, digital elevation model, or triangle irregular network model. This is most important because in DEM is nothing but it is the digitized version of a contour map. It is the digitized version of a topography. Okay. Ultimately, this both has the same with some basic difference. First, TIN is created from the contour or RL, and then it is converted into this raster of this which is known as DEM. Okay. So, because here flow, when after the river flow is just water is overflowing, and how it will flow. So there is our main Manning's formula. V is equal to 1 upon n r raised to 2 by 3 s raised to 1/2. Okay, so that s raised to 1/2 is taken care of by this DEM. That is what slope. It is what topography. So DEM is invariably required. LULC map. It is a land use land cover map, because when the water is flowing in a river has some different value of n, Manning's constant. When water is flowing on the surrounding region where there is a number of types of land covers and land use are there, maybe muddy surface, built up area, grass, vegetation, dense vegetation, even water body, and so many things are there, and accordingly the value of n will change. Okay, and the flow conditions which is required in HACRAS. Okay, so I have just taken one example of a Baxter river. It is just fictional, and how it is being done. Okay, meanwhile, just let me have Dr. Raghu. Hello.
Sir.
Hello. No, if suppose if somewhere when you want to interrupt me or you want to stop me, just you tell me, okay? So that I can, because here when I am making the presentation, I cannot see this interface. Only presentation is there with me. Okay. So anytime you want to stop me, you just tell me. Okay.
Okay, sir. Okay, sir.
Okay. Just I'm sharing once again. I am going to the PPT. Okay, PPT is coming once again.
Coming, sir. It's coming.
Okay, so this pre-processing, model execution, and post-processing. Actually, pre-processing here, there is a two type of data or two type of work is there. Geometric data and flow data. Okay. So that is important. Geometry, that is nothing but it is a river and the surrounding region, and flow, that is nothing but it is the discharge from the upstream side and what are the downstream boundary conditions. And then post processing means ultimately the result, the product, that what is a inundation. Okay, now this is a conceptual diagram is there. First of all, we must have this DEM or topographic map. We have image. If image is not there, then aerial photographies also work. And we have to pre-process in ArcGIS, and using the HackGRS, we have to send it to HackRS. In the HackRS, there is a processing, the model is run. Here, flow conditions are edited or flow conditions are incorporated in HackRS only, not in GIS. And after that, once again, the things are going to ArcGIS through HackGRS, and finally, we will prepare the flooded map, which is called flood inundation map. Okay, now here, this is a, what I can say, flowchart is there. DEM, here image, Google Earth image, any image you can take. GIS data development, then generate RAS GIS import. This is important, RAS GIS import file. Okay, and here this is RAS GIS export file. So when, just I will explain, when we will going from ArcGIS pre-processing over, generate RAS GIS import file. Okay, so that file, we are, entire our work is ready in this form, and it is going to the HackRS. Similarly, when in HackRS our model is run, we will generate this RAS GIS export file, and it will come to ArcGIS. And using that file, we will make the flood analysis. Oh, sorry, I mean flood inundation map. And in that map, we can have the depth also, and so many things are there. So this is the entire framework. Just I will go into the some conceptualize things. Okay, so in this pre-processing of data here, just what is to be done, this is just the digital elevation model of some region. Okay, here the pre-processing means what? When we have the image or any other aerial photo, we have to create this themes. Stream center line, that is river center line. Main channel banks, that is the bank of a river. Then flow path and its center lines. Cross section cut lines. Bridges, inline structure. That are the linear feature. And that is also in GIS terminology, you can say is this is a vector format. Whatever the DEM is there in raster format, but raster and vector is the things we will not discuss here at present. But these are the themes. Linear theme and aerial theme are ineffective area, blocked obstructions, and Manning's N value on the basis of land use land cover map. Okay, so here, just okay, here at this present, just I want to make the this ArcGIS interface. Are able to see this interface?
Yes, sir. Yes, sir.
Okay, okay, fine. Now actually this is okay. I will just give you the things. This is ArcGIS, okay, an ArcGIS interface, and GIS is a layer wise structure. Now here you see all these layers are there, and it is a Baxter geometry. The name of the river is Baxter River, and it has some diversion here which is known as some creek. In that they have given the name Tule Creek, and this is the further the river is going on. Now here I will tell you about this. This is HeckGeoRus. I told you ArcGIS and HeckRus. In between, this is the HeckGeoRus, and here HeckGeoRus is cannot be operated as an individual. It is the part of the tool of ArcGIS, but HeckGeoRus we have to installed, and after installing it will appear as a tool in ArcGIS interface. So here RAS geometry we have seen that create the RAS layer, and here all the layers are there: stream, center line, bank points, flow path, access, cut line, breach, culvert, okay, and this so many things are there. So this is okay, and once again I am just keeping these tools. So here all these layers are there. If you will see, these are all the layer. Okay, you see this yellow one is the river center line. Let me have that arrow. Okay, so this is river center line. These are the cross section. These are the bank line, and then this is the flow path line. Okay, so that everything should be here, and that is mentioned. What is a flow path line? Yellow. Access cut line, this blue. Okay, and these are the block obstruction. Okay, this block obstruction or ineffective area, that I will explain later on. But this thing, how this thing we have to create, okay, by using the digitization tool, we have to digitize all this. If you will have this photo here, I will make this all this sorry, switch off all the layer. Okay, so initially I have this thing. This is my river which is going on, and this is the creek. So now all this theme, levee point, storage area, inline structure, lateral structure, levee, bridges, everything that I have to digitize here using digitize tool. Here I will not mention that digitize tool and how to digitize it, but this thing say the flow path. Okay, this is the flow path and center line which I have digitized using the digitize tool. Okay, this is the center line and this is the flow path line. Similarly here, these are the banks. Okay, river bank I made it digitized. Then this is the river. Okay, this red one is a river center line which is overlapping with the flow path line center line. Also, river center line is actually river portion where water may be there or water may not be there in some portion, while flow path is that where only water is there. But normally river flow path line and center line we are taking it as a same. Okay, so this all these things are to be digitized, and ultimately we have prepared these things. All these are the themes or layer. Okay, and this will give me the full extent. Once again I will take it. So here what is actually the things? The thing is that from this river high water is coming, and when this water comes, and it will overflow this bank, this pink line bank, and it started inundating these areas. Okay, so here now blue one is a cross section, while green one is a bridge. Okay, means in a river, after this here there is a bridge is there, that also we have to locate. Okay, of course I did this thing for the Surat and Tapi river, and at that time 4 to 5 bridges were there with one weir. Okay, so this is the things, and this is the pre-processing we have to do. Okay, now here just I will add this LULC. This is the LULC map. This is full extent. This LULC map is of all the surrounding region, but wherever our river is passing and our cross section area is passing, if I will make this tin disappear, so now you see here that my water will pass through river as well as in a flood condition. It may pass here also, it may pass here also, on both the side. And at that time here, which type of land cover is there, accordingly value of n we have to assign. Here if I will open the attribute table, so here you see here LU code. Okay, near stream, urban farming, urban farming. This is their industrial, SDR, residential, open space, open water. So in this accordingly we have to give the value of n, and we have to assign. So okay, so first of all this class LU, land use land cover class, you have to evaluate. I mean in LULC map how. Now there are also first level 6 class, second level 27, third level 81, fourth level more than 409. Now fifth level and sixth level classifications are also there, and accordingly you have to put the value of n, which you have to define that in my LULC I am going to put only 6 class and 6 n values there. Now HECRUS has a constraint that for a particular one cross section it cannot take more than 20 n value. Okay, means one cross section, if it passing through the different types of surface more than 20, then it will not work. Okay, but that is in HECRUS 4.0. HECRUS 6.0 it may be working. So this is the things which pre-processing. Okay, so now I am once again coming to the presentation mode. So just what are the things are these are the okay. Okay, these are the creation of theme which is created in ArcGIS using HECGeoRus. And what is stream center line, which is here mentioned here. This is the stream center line. What is the main channel banks here? These are the main channel banks. Okay, individually taking the snapshot, I made it here. This is the flow path line. So flow path line is this, and it is they will ask the software whether it is you want to coincide with the center line. Normally we have to say the yes. Okay, because it is very much difficult ki kahan ka, if you can say that here water is not there, the flow path line will come here. If here water is there, then flow path line will come here. It is better to take the center line of the river, and flow path line center line is the same. Okay, then cross section cut lines. These are the cross section cut lines. Okay, cross sections are there. Now here it may possible that if you will make your cross section up to here, but water, flood water may go up to the here, and accordingly you will get the bounding polygon or inundation map. This is bridges and culvert like this. This is the bridges I have mentioned here. Okay, so this is the bridges, and this is known as a thematic map, or it is known as thematic layer. Why? Because it is a theme wise structure. What is the theme? Cross section theme, center line theme, bridge theme. Means in bridge theme means here you must have 2 bridge also or 5 bridge also, depends. Okay, inline, creating ineffective flow areas. These are the ineffective flow areas. Now what is actual ineffective flow areas? That is the identified non-conveyance area with water but no velocity or zero. Near the bridge pier, some area is there where water retains there, but it has no velocity, it will be steady there. That is a ineffective flow areas. Okay, so HACRUS does not store all information about ineffective areas, instead only information where the ineffective areas mainly interfere with the cross section flow, that is the stored. Similarly, blocked obstruction. Blocked obstruction means it is the represent blocked flow areas, means areas with no water and no flow. Here no water and no flow. Here water is there but flow velocity is zero. That is the aerial, these are the aerial thing. Okay, so and this is the Manning's coefficient LULC value you can assign. And here is in actually the gas interface, I mentioned that it is a which type of landforms are there, and accordingly n value we have to give. Okay, okay. So now after this, exporting the data to HACRUS. Okay, so this is the last step to create GIS import file for HACRUS, so that it can import the GIS data to create geometry file. Before creating an import file, make sure we are importing the right layer. Okay, so it is here. Let me come once again into the software side. Sorry. Okay, here this is the export data. Okay, so here if you will make here, you have to just take what is the RAS file name, and if you will see, its name is normally GIS to RAS, means the file is going from GIS platform to RAS software, or ArcGIS software to RAS software. And then you have to take, and then you have to say the okay, or and then this file where you want to save, that also you can give from this folder. So here our geometry is over and we are exporting data to the HACRUS. Okay, now up till now we have not given what is the flow condition. Okay, so these are the steps and you can transfer it. Okay, here they will ask us this type, and then you can give that, means these things here written that all the correct layers are not there or not, so that you can check it by this stepwise procedure. Okay, surface layer, optional table, that everything will be mentioned here. Okay, and you are giving it to the HACRUS, means that GIS to RAS file. And after verifying, click on RAS geometry export GIS data. Okay, and then this is the file will be in form of .sdf. Okay, so that file is saved in your required folder in a form of GIS to RAS .sdf. You can change the name also, but as far as possible, the default name GIS to RAS you can keep it. Okay, so that it is easy to understand. In future also you have did the work, but then after, then what is this name? If but .sdf format, it indicates that it is GIS to RAS file. Okay, save the map document. You can either close the ArcMap session or leave it running. Okay, means you can save it or you can close it. Okay, that is up to you. Okay, so now after this, just we will go for the hackers. That is the model execution. Okay, so just I am let me first explain you the some basics of hackers, and then we will open the hackers window. Okay, just 2 minutes. Okay, just for drinking the water, I called my son to bring the water. Okay. So this is the model execution, and here in this phase, your data created is imported in hackers. Now here we have to save the project first, and here whatever is there, the file name is Baxter or any other thing is given. Okay, now when you will import the data, it will ask you which unit you want to work. I mean our SI system, metric system, or foot pound system, FPS, whatever is there, we have to select it. Okay, and at that time it will ask you. Okay, now these are the data imported into the hackers. Okay, so now we will go for hackers interface. Already it is there. Okay, are you getting this hackers? Please,
Yes,
Dr.
sir. Yes,
Raghu.
sir. Yes, sir.
Okay, okay. Sorry, let me close all this window. Okay, now are you able to see the hackers window on my desktop?
Yes, sir.
Okay, so here we have to open this hackers. This is 5.07, and even HackJRS version is also updated version, and ArcGIS is also updated version. So here, this is the project I have created here. New, whatever in a PPT it is given, that new project. Okay, and new project you take, what's the name you want to give, you give it. Okay, and you save in a particular directory or the path. So I have here, so my pen drive is also there and my PC hard drive is also there. So accordingly you have to save it. Okay, and meanwhile your data will be coming in a hackers. It already it has come here. So let me cancel this, and here there are two data has come in hackers. One is Baxter geometry, means what the things we have prepared in ArcGIS. Okay, and another one is a Baxter flow file which we have to create in hackers. And then after third is we have to run the model. Okay, now here one thing which I want to discuss with you is this geometric data. Now this 5 point, this is the things which I did in ArcGIS. Now here also directly in 5 point hackers 5.06 you can create all this thing. Okay, all this line and this cross sections lines and everything you can. Here it is the Baxter River, here Baxter River, this is Tule Creek, everything is there, and here there are all the data you can create here. Okay, and what is here, you see, are you getting this red dot? So this red dot is nothing but it is the indicates the bank point. and after the out of the red dot, there is a floodplain starts. That is the meaning. So this type of the things are there. And here, this is a bridge where I put my cursor. But this geometric data is here. We have to see and we have to check the geometric data. There are still something is remaining. Okay, what that something is remaining in the geometric data, just we will see here in the presentation mode. I am coming. Okay, so this is just how to, this is the new project. This, it will take this name or this extension of its own by default. Okay, then you select these units, then this will the river stream cross section and this storage area, and that everything it will be taken, and you have to, after checking, you have to make it okay, means accept. Okay, so these are the data which is entered into the HECRUS. Node name, GIS cut line, that is cross section line, station elevation, that is from the DEM, reach length, that is the river length, river central line length, bank station, and Manning's N value, which is there in a Manning's N value is there in Manning's table. We will see. Ineffective area also, if we have given block obstruction also, it has come. Okay, so these are the things I have come here, and you can say finished import data. So that what the HECRUS interface I have mentioned just before will be created. Okay, so now after this, this will be the scene which we have already seen, and here we can have to modify or correct or rectify some geometric features. Okay, so that is the geometric data editing. So here cross section, bridge, inline, Manning coefficient, that everything has been there, but here you have to see, you have to open the cross section, and what you have to check the value of n and other things. So if you will find that this cross section is not proper, how this cross section has come in HECRUS? From the data which you have exported, and in original ArcGIS file you have used the DEM. So that DEM will give this cross section. Now I am once again going to the GIS, I mean here, and I will make all this layer off, and I want to give you something. Okay, now here this is a DEM. How? So if I will take any cross section, interpolate line. Okay, if I will take this section, okay, so I have taken this section where this is the river part is coming, and then I will see that profile graph. So this is the profile graph where this point is there. It is the bottom point, Thalwage point. This is the river bottom, and these things has been the my cross section. So how this cross section has come in the HECRUS? Because of this DEM. Okay, this is the digital elevation model of a Baxter River region. Okay, so once again I am going to the PPT mode. Okay, so that's why this has come, and there is a elevation of this point, and these two are the bank point, and the remaining points all are overland flow or floodplain. Okay, so now here what you have to do here. This is the cross section editor is there, where you can change if you find some error. Okay, by checking the ground truth, you can change it here in this graphics access graphic cross section editor. Okay, I'm once again I'm opening this here. So here in a cross section editor, this is the things, and you can. So here what happened, this cross section I have opened, and in this cross section if I will find something wrong, okay, मुझे लगता है कि this station should not be here, or here this indicates water, but I say that no, in a ground truth here water is not there, here it is just the flat surface, just take it granted, then I can edit this thing here. Okay, I can edit this thing here and I can make, and these two and this are here. Once again they have mentioned the bank station 3, but no, I can edit it. So this is the geometric data editor. That is the one thing. Here if suppose I want to check this cross section here and here, edit cross section, once again you can edit this cross section here. Okay, so then after in the presentations it will come is a bridge data. Okay, so bridge, what happened, we have given the location of bridge, that bridge is here at this junction, but bridge is resting on pier, how much piers are there, what is the length of a bridge, what is the abutment, what is the length of each span of bridge, what is the width of pier, that every data we have to give here. What is the deck and roadway, pier, sloping abutment, bridge modeling, culvert, okay, multiple, this everything we have to give here. Okay, so just in a PPT I will mention you that what is this things and what is the distance, width, bridge crested. Okay, here there are something is written in 1200 feet width of bridge and other things are there. So just the things. Then here also how many piers are there in this bridge in cross section. Okay, this is cross section, left bank and right bank, and this is upstream and downstream of that. So you can give the number of piers and other things. Okay, and you can add this to geometry, because that thing we have not provided in ArcGIS. Okay, so this is the geometric data editor in Hackers. So here you can have geometric data, and in geometric data you go to bridge and culvert. Okay, and here if we will find no data, because here the data is not given, that's why it is a blank. Okay, so and this is the river reach here. Now here this 2D area or 2D flow area or this grid you can directly prepare here also. Okay, so this is the geometric data editor where we have to check the cross section and we have to give the details of bridge, pier and bridge deck length and span. Okay, so this is there. Now the main important thing is there, that is nothing but flow data and boundary conditions. Initially I told you that flow data. So what is the flow, how much flow is there in a river during the flood time, or in river if there are 5 lakh cusecs of water, then it may start over flooding or overtopping the bank, that may be there. So here we have to go to the flow data. Okay, here uh, we have taken the three hypothetical data with a different value of a discharge Q from the upstream, and we have curated three profiles. Okay, so just here these three profiles are there. We will see. So here how to do this thing. I will close this geometric editor. Okay, edit steady flow data. Okay, I have to, this is the data, and here you can create the profile. Three profiles just taken, profile 1, profile 2, profile 3. You can create more profile also. 4, oh sorry, 4 profile also. Okay, then here the boundary conditions and other things also you can give. So here this is the river is what we have: Baxter River main, then Baxter River after junction, and the creek. Okay, so that's 3 is there, and the river stations are given. And profile 1, 2, and 3, you have given this different discharges. Okay, so this is the discharge 24,000 cusecs, cusecs. This is 48,000 cusecs, 96,000 cusecs. And when junction comes, so in a downstream Tule Creek, how much it go and how much will go to the main river, that is given. So here you can add a flow change location also, okay, if you want. So that is the things as per the requirement. Then here in this you can have new flow data, that also you can take, or you can edit this data also. Okay, what is the upper reach, what is the lower reach, or multiple or reach the boundary conditions. So here Baxter River upper reach. Okay, what is the upstream condition? Downstream condition is junction 2. For so actually here let me have you once again the things with our because yes, here actually for first river Baxter River, what is the upstream condition? That is the what is the flow here. For this Tule Creek and for this part of the Baxter River, upstream condition is junction 2, whatever the flow is here. Okay, that is the meaning of this GIS HECRUS. Okay, so here what is this junction 2? You can change it. Okay, what is the depth and other things. Now here when you want to give here boundary conditions, you can give it by the 4 method, either some known water surface, critical depth, normal depth, rating curve. Okay, and you can here this delete or add, that can be done here. So here you have to give as per the data available with you. Okay, particularly in the case of Surat city, it was having the upstream condition at the flow discharge from Ukai Dam, and downstream condition is near Magdala, where there is a tail water, sorry, tail, and there is a backwater from the river, okay, of a tide was also there. That was given as a downstream condition in case of my research. So here you can give the flow conditions, you can give the different options here, okay, which is there in the HECRUS. And you can save the flow data, rename the flow data, and you can do the things. So just we will exit the data editor. Once again, we are going to our presentation. So flow data and boundary conditions which has been given. So here this is the flow data is given, flow change, boundary conditions. Okay, that everything is here. We can do this thing in a hackers. Okay, what is the profile? You can say the normal depth. Whatever you will select it from here. Okay, the bound for the boundary conditions. Set boundary for one profile at a time. This is if the profile you have only single profile, you can do it. And now then save. Okay, and that data is saved as a flow data. Okay, previous data was saved as a geometric data. It is having G extension dot G something, and here it is extension is dot F when flow data is stored in a hackers file, hackers format. Okay, now we will go for steady analysis. Okay, and as per our condition, subcritical flow, supercritical flow, or mixed flow, we will make the plan. We will make the plan one. Okay, and we will just start the computing the things. So select here, particularly in this example, subcritical flow regime is selected, and then click the compute, and the work is just like this. We will find this is the computation is going on, and that snapshot I have taken here. I am going once again to the window. Okay, so in this window, edit, geometric data, and steady flow data. Okay, now run steady flow data analysis. Here you can do number of things: water quality analysis, hydraulic design function, even sediment data, everything that you can do. Particularly here in this for flood inundation map, I did the work. But here this software is also so many functions. 1D and 2D model you can do here. The let me explain you just the things. That is 1D model means flow is there in a river and how it is increasing 1D in only one direction. But when it starts overflowing, that is the 2D. And there are 1D and 2D coupled models are also there. Okay, so this is the 2D model. Now I am coming to once again to the here, and now run the steady flow analysis. Okay, so here I have the plan. You can give the plan means what? Actually different alternatives you can give here, and you can give the options also. Okay, flow distribution location or any other things. And then after selecting open a plan, so I have two plans. Okay, and you see here there is a things which is the location or which is I have saved, that is given. It is too long path is there, but you can select plan one also, and here okay. Do you want to save existing steady flow data? Yes. Okay, now this is a plan one, and now I will start that compute. Okay, so you see here this is over, and already the work is over. Computation summary is there. Now if is there any error, because this work requires lot of time. Okay, so here if for this running of this, there is so many changes in sections. We don't know exactly in a river Tapi section. This is just one hypothetical example. It is there. But to run, I have run actual model for the Tapi river, and I have given the inundation area. So just exit, coming to the PPT once again. So this is the over, and now exporting HECRUS output. Okay, so data from the HECRUS, we have 3 profiles selected. So that data we have to export into the HECGeoRus. So click on select profiles to export button. Choose the profile you want to export. For this exercise, choose the button. Okay, maximum flow or whatever you want to make it. So here, this is GIS export file. Okay, and you can take, you can select all profile also, or any single profile also. Here, why is this single profile is selected? Because this single profile is having maximum value, I think 96,000 cusecs, 24, 48 and 96,000. Okay, and then click on export button. You will create a SDF file in your working directory. Okay, once again it will create the data. You just make export data. Okay, and this will be SDF file, RAS output file, SDF will be exported and converted, okay, in XML file. So what happened now? This is the post processing visualization. So we have to go into the ArcMap. Already here we have already given export data. Data is exported, and now after this, once again you have to come to the ArcMap. Whether we have closed then open. If it is open, then you can do the work there. So here convert this RAS output ASCII file to XML window or XML format. Okay, and with this extension. So here once again we are coming to the ArcGIS. Okay, so in RAS mapping here, this is a import RAS data. Okay, so RAS file you can import. This is the import RAS data, means you can take it from HECRUS, which is already ready file. Okay, Dexter.prj. Okay, whatever the name is given. So that file you have to export here. Okay, after exporting, it will convert it into the XML format. And now here, this is the post processing. Okay, so now after this, they will ask you whether this is the terrain type of what, teen or grid. Teen is triangle irregular network, and grid means it is a raster. Okay, it is having the square grid format that is there. Whatever is there, you can use. Here we have used the teen model. In my thesis, I used the grid. That is the Surat City DEM raster format. Okay, now here the flooded area delineation. Okay, so your work is over. It is already here. It is already here. It has come here, and now I have, this is the window which I have prepared pre-processing. Now I will open another window. This is the post-processing, where this area is a bounding area, or this area is a flooded area, and you can find the depth of flood also. Okay, so here what we have to use this RAS layer. Okay, so these things is here we will go to this. Okay, so now flooded area delineation. So click on RAS mapping, read RAS GIS export file, means HECRUS to GIS file which we have export. This will create a bounding polygon which basically defines the analysis extent and access cut line and other things are there. Okay, so now click on RAS mapping, inundation mapping, water surface generation, and select the profile PF3. Okay, here, so just okay, you come to here. Okay, here inundation of mapping, water surface generation, floodplain delineation. Okay, these are the commands. So after this layer setup is over, import data we have already taken from the HECRAS. Go to here, water surface generation, floodplain delineation. Okay, and you will get here this different. I will just make this tin on all these thing. Okay. Okay, so now here you will get the things. This is the river 2D, this is the river central line, this is the bounding polygon up to which the water will go. Okay, if 96,000 cusecs water is released, then this much area of surrounding to Baxter river is inundated. Then this is the bounding polygon. Okay, and this is the excess cut line which is mentioned here, and this is already the DEM which is there. Okay, so that is the thing. So here the stepwise process is also here I have mentioned. So that grass mapping, inundation mapping, water surface generation, then select the profile, and this will create the surface. Okay, that tin TP03 here. Here this is TPF3. Okay, that everything one by one, all this bound BAPF3 access cut line, bounding polygon, and everything will be created here step by step if you will go here. Okay, and then after converting the water surface tin into the grid. Okay, so this is the inundation of the mapping, floodplain delineation, grid intersection, and finally you will get the depth of water. Okay, so here this is flooded area delineation. Okay, now then after this is flooded area delineation with bounding polygon. Okay, and now this is the flooded inundation map depth of flood water depth. Okay, so here this is my inundated area, but if you will put here, then green legend says me that here the water is of 7 feet to 13 feet. Here the water is of about 13 to 21 feet. Okay, and this dark, most dark portion, it is 21, and white portion it is 30 feet to 40 feet, which is already the river portion. And somewhere here this blue portion or this sky blue portion, there is a 7 feet water is there. So this is flood inundation map showing depth of the water, and this can be here okay, you can take it from here, and this are actually all the things. So now what I want to say, the nowadays the RAS geometry you can directly create in the HECRAS, which was previously not there. I have used ArcGIS 9.3, HECRAS 4.0. But when you want to prepare this map post processing, so that post processing is done only in this RAS mapping, layer setup, import data, inundation, water surface generation, okay, visualization, 2D animation, that everything you can do it here. And you can create ultimately the flood inundated map, which will give you the depth of water also. Okay, so here the same Okay, and here just I am ending with my lecture. I think that there is not much more
Yes, sir.
time I have consumed. So
No, sir, you are in time only, sir.
okay, in time, because accordingly 1.5 hours you have given.
Yeah, now we will go for a question and answer session, sir.
Yes.
Yeah.
Can I? Okay, no, I am keeping everything open.
Sir, right. I'm requesting all the participants, if you have any questions, please.
Yeah. Otherwise, they can type it in the
Chat box.
chat box. If at all, we'll take it later.
Mail. Yeah, yeah. Sir,
Okay,
could you please provide your mail?
I am. Acha. Anybody wants write in chat box? Okay, no problem.
Sir, or else if you wanna contact you, we will contact you through mail if you provide.
Yes, yes. I will provide my mail is there with you. I think so.
Yeah. I will mention
My
here.
sorry, my email ID is also there and my mobile number is also there.
Yeah.
So,
Okay.
because of if you want some detailed queries there, then we will discuss separately. But something superficial, if you want to ask, because now the DEM, this is the DEM is a SRT. Yes, please, Abhilash. हाँ अभिलाष जी, आप कुछ कहना चाहते हैं?
Abhilash?
Yeah. Sir, Abhilash. I'm from RNSIT,
This
Bangalore.
PPT
I'm an
to
assistant professor.
Dr. Raghuji, okay, and accordingly with the material they will accommodate in their material, okay, so don't worry for that. So anyway, just at lastly only I will just tell you that this is a water management and GIS, but if whether you may not be having the water resources, but if you are there in some structural side, soil side, in a soil there is a soil category and other things, everything that you have to use this GIS tool. And this GIS tool is basically coming under geospatial technology, GIS, GPS, global position system, and remote sensing. All these three are together, and they three are used very much for the research work and solving our problem. But somehow, what I can say that due to some X factors, whatever the research is going on in our India or anywhere, particularly Indian context, it's a very good time. And people, students, everybody, researchers, professors, they are making the good effort and they are spending their lot of time. And finally, if we submit this proposal to the authority, कि तापी नदी में से इतना मिट्टी निकालना है, then after it becomes political issue and our all efforts will be there in a black box. Anyway, that is a unfortunate part, but okay. So thank you Sasidhar ji and thank you Raghu ji. Okay.
Professor.
Sir, one thing, sir. One thing. There is a question
Yes.
like this, sir. How does climate change impact water resource availability and flood risks?
Yes, please. I think in chat box that question is there. I am reading this. How,
Yes, sir. Yes, sir. Yes, sir.
Govind ji, how does
Govind Dake.
climate change impact water resource availability and flood risk? Okay, actually, this climate change is a very much today. It has much more impact. I mean, it is climate change is everywhere. It is coming, and particularly when the climate change is there, that water resources availability is there. It is what you there due to the human activities and human intervention, water resources are affected. But due to this, actually what happened, the different types of human activities will damage or will deteriorate the climates, and due to that there is a what we can say the global warming is also there, global cooling will also be there. This time in 1973, 1989, there was the severe cold in India, and now this time also it will be there. Some I have just came to know. So that is the thing. Water resources, climate change has very much impact. As far as flood is concerned, there also climate change in that way that if there is a rainfall pattern changes. Before I think 3 years, in month of December and January in Surat, winter is there, and of course about 18 degree or 20 degree temperature, but rainfall was there. So such type of a climate change study, which is a very vast subject, if it is a climate is changing, it has the adverse effect on rainfall also, and even global warming and global cooling also. So due to that, water resources or water availability or groundwater or surface water, it may have. And apart from this, pollution, it creates pollution or some other odd effects is a separate one. Okay.
Yeah.
So I have a question.
Yes, please.
Sir, till now what you spoke is for river flood management, right, sir? I wanted to know a little bit more about canal flood management, sir. Canal flood
Yes.
flood management.
Actually, that is canal flood management here. This is also the river, and but the canal means the canal is receiving water from where? What is this
From the
here?
river itself, sir.
No, what I want to ask, river, and this particular case, it is receiving water from the upstream or the dam. Okay, particularly Surat Tapi river, and that is there. In Narmada river, in Narmada canal, Sardar Sarovar dam, there is a Narmada river is also there, and there is a canal is there which is going up to the Rajasthan. So canal, in your case or in your context of your question, what is the source of water in canal?
From the dam itself, sir.
From the dam itself. Then it is if by chance in the dam, in the dams they are really releasing the water, high water in a canal which is irrigation purpose, and whatever due to some or other reasons, not in a mainstream, but if it is going in a canal and canal is overflowing, but here what is the difference is there, the canals, whatever you are saying normally is a lined canal, concrete canal, and their velocity and other things are differently changed. So process basic remains like this, but an LULC and river means canal itself, cross section will be the governing or main changing factor. Otherwise, it remains the basic concept remains like this.
Yeah. Sir, we have Lacey's method and Kennedy's method for designing a canal. Sir, which is the best suited for flood management, sir? Is it Lacey method or Kennedy's method?
There is, I will tell you, Lacey's and Kennedy, there is a one method is a practical profile. Actually, how I can say practical profile is trapezoid, but here at the bottom, there is a curvature is there, which I proposed for the river Tapi. Okay, so practical canal section, which I propose for river Tapi as a curative measure, so that practical canal section you can take. Because I think Kennedy's theory is Upper Baridob river in Punjab. I think so, and that conditions may not be prevailing in other rivers. Okay.
Okay,
Yes.
sir. Yes, sir. Thank you, sir.
Okay, welcome. Okay, Raghuji.
Sir.
Yes, please.
Sir, any question from the audience?
No problem. You can contact me afterwards.
Right.
Also, you can contact Dr. Raghuji, and then no problem. Because sometimes what happens?
Right, sir. Sir, thank you, sir.
Okay, no, Mr. Naidu, Dr. Naidu has posted. Let me see. Where is your question, Dr. Naidu? Please. One question I
Sir,
posted.
there is a question. Sir, you have a lot of work, Baxter River. What is the response from government done?
No. This Baxter River is just a fishious. I have worked on Tapi River, same, but it is at that time in Tapi River. At present, I am not able to show you. I worked on Tapi River. This is first of all I learned myself, and then after I work in Tapi River, and Tapi River for that Hector's model running, number of time errors has come, कुछ ना कुछ तो उसपे 6 महीना 7 महीना लग जाता था. Okay, so that is and there I did a lot of work in Tapi River. So okay, हाँ, yes, गवर्नमेंट, so ये सेम वर्क है ना, ये मैंने कॉर्पोरेशन में भी दिया था. और एनीवे बाद में व्हाट आई कैन से एक्स फैक्टर, वो क्या, वो तो बोलते हैं ना कि अगर before 2 years or rather 3 years before corona, my colleagues, me and my 2 colleagues were just have a discussion with the corporation authority to make the dredging. Actually at that time dredging word was banned by Supreme Court. I don't know now what is the situation, but we have used the word removal of materials. Okay, removal of sediments from that Tapi River. But that project was, there is so many, because when you will make dredging or when you will make removing the sediments from the river, then you will get so much valuable materials and other things, and that can be used. So there are some political issues and other things were there, and ultimately that was stopped. Okay, so at that time somebody with some executive engineer of Surat Municipal Corporation, we were sitting and just comment was there, अगर मोदी साहब यहाँ पर कुछ स्पर्धा करवाना चाहते हैं तो ये हमारा प्रोजेक्ट वैसे हो जाएगा, कोई टेंडर नहीं, नथिंग, नो, एंड लाइक दैट. So anyway, I told you that there are some X factor, but anyway, we have to keep working.
Sir, there might be a last question from Abhilash.
Yes, sir. Which is the
Sir,
base design aspect? Which is the base canal design aspect? It is using critical velocity or using slope? I think so that slope is changing with respect to time. So if you have designed it with the slope, but after 5 years sediments or whatever it may be, of course it is a lined canal, then slope. Otherwise you can go for the critical velocity.
Yeah. With this, I'm going to close this question and answer session. Sure, I will share the details of Professor Agnihotri with you all. You can contact him by phone or mail. Then you can discuss with him and you can continue your research at a significant extent. Right. Thank you, sir. I'm very happy to have you at our faculty development program. Being a student of SVNIT, I'm very happy to have you and Kondraivendhan sir in the first session of FDP. First, it is our heartfelt gratitude to Prof. Agnihotri for your insightful session. And once again, thank you for sharing your time, expertise, and passion with us, sir. We look forward to more such valuable interactions in future. Thank you very much, sir. Over to Professor Shashidhar. Sir, are you there, sir?
Thank you, Professor, once again for sparing your valuable time. We know that it's hard to request for a lecture at 7:30 in the evening, but the guidelines are like that. Even then, they have a beautiful session. I've been throughout the content hearing. So because even though I was from structures, but you have enlightened what is happening, everything, including this GPS and all, sir. Hope the students also enjoyed. Almost 150 faculty are there online.
Yeah. I 157 numbers were there when I entered.
Yes.
at that time Kondraivendhan sir session was going on. Anyway,
Yeah.
Yes.
So thank you
Thank
all
you.
of you.
Once
And,
again,
Sir,
thank you,
1 minute, sir.
yes, please.
I kindly request all the participants to turn on your cameras for a group photo as a part of ACT rules. I request all the faculty, please turn on your cameras. Yogi, are you there to capture a photo? Yeah. I agree. It is not correct time to ask for photo, but please.
So just have a snap. Okay, or on
No, Raghuji,
almost. Yogi, please close it as soon as possible.
Raghuji,
Sir.
just
Sir,
you can keep your background as some like my background. You can keep.
Yeah.
Need not to worry.
If you are inconvenient, you can blur your background.
Mhm.
Yogi, have you done?
Yogi, finished?
Thank you very much, sir.
I hope we'll see you all tomorrow evening once. Okay.
Yeah, thank you, sir.
Yeah, tomorrow, like, two sessions. One
Okay, thank you, Raghuji. Thank you, Sasidharji, and thank you
Sir,
all.
thank you, sir.
Thank you.
Thank you,
Good
sir.
night.
Good night. Have a nice day.
Thank you, sir. Yeah, participants, we have two beautiful sessions. One is from Pawan Anantarani, works for Christchurch University, New Zealand. Another one is Dr. Venkatramana, professor of VTU Davanagiri. So see you all tomorrow evening, please. Good night, everybody. Thank you very much.
Good
Yeah.
night, sir.
I request all the faculty to fill the Google form twice, each for one session. Right? Don't forget to mention the resource person name in that Google form. Thank you.
Thank you, sir.
Thank you, Yogi. Thank you, everyone. Bye.